Okay, sixth graders. In lesson 2.5, we're going to be making some tables. What did I just say that tables are used for? Emily? Organize information and look for what? Ariana? It says on the board. And you wrote it down. Organize information and look for patterns. Look for patterns in numbers. Right. The table is organized with the title at the top and then in columns. The columns are the subjects. They're usually labeled. Okay? And then the data should go down in a pattern. So highest to lowest, or lowest to highest, and so on. Okay? Let's take a look at the assignment for today, what you're going to be doing. It says, the Booster Club is selling bags of chips for 55 cents, popcorn for 90 cents, gum for 85 cents. Jordan has $2.50. If he wants to buy either all chips, or all popcorn, or all gum, what is the greatest of each that he can buy? And then you're given a blank box. You're given a blank box like this. Okay? What is the title? What are we going to do? What are we going to put at the top of this box for a title?
What Jordan can buy.
Yeah, okay. What Jordan can buy? For how much? How much does he have? $2.50. So that means that whatever we find, it's going to have to cost less than $2.50. Right. Now, what are his choices? Chips, popcorn, gum. Any others?
No.
So we're going to make, if we're going to make two columns, what should we label those columns? The title of the columns. Right. Chips, popcorn, gum. And then these are what's the title of this column? Cal? Snacks. Or choices. Then, is there anything else that would be helpful information over here?
How much each one costs?
Yeah, how much each one costs. So maybe next to it, right? How much are the chips? 55 cents. Popcorn is 90 cents?
Oh,
Yeah. 90 cents.
And the gum is?
55 cents.
Now, what should we put over here? So we've got, what do we need to find?
how much you can buy of each?
Okay. So cost. Right? Isn't that what we're gonna find is the cost
Oh,
of
no, we're trying to.
how many he can get, right? So, how many chips do you think he can buy?
Oh, I know.
Well, if you count by, let's say if we round this to 50s, 4. So how would we find the total amount for that?
Well, you just do 5 times 4.
5 times 4?
Yeah,
then you could add a 0.
5 times 4.
How about, okay, 5 times 4
And then
plus,
and then you do 5 times 4 again.
but isn't it 55 cents? So 50 times 4?
Yeah.
Yeah.
Okay,
Exactly.
yeah, if we broke 55 into 50 plus 5 times 4, what would that equal? $2.20? So, for chips, how many could he buy? This proves that he could buy how much? 4 bags, right? Or 4 chips. How about popcorn? Carson. 2. Because 2 times 9 is, so 2 times 90 is 180, or $1.80. So 2 times 90 is 180. Could you get one more?
No.
No. So 2 popcorn. And how about gum? Well, if 2 times 90 is 180, what's 2 times 85?
6, 7,
170. Is that enough for one more? Could you get one more of those? What would the change be? If he has $2.50 and he gave them $2 to pay for the $1.70 for the 2 packs of gum, what would this change be?
wait.
Oh, it would be 85. No.
So if you gave the
It would be
gave the person
87.
$2 minus $1.70, how much is the change?
No, he can't do it.
Oh, by 5 cents.
How much is the change?
5 cents.
No, $2, because you wouldn't give her all $2.50 if it only cost $1.70, right? However, you could start with $2.50, but let's just pretend that we're up at the counter. We're buying the gum. She says that'll be $2 or $1.70, and you have $2.50. So if you have $2.50, you have $2 bills, right? And 50 cents. Would you give her all $2.50? Why not? Right, exactly. You would give her the $2, right?
Yeah.
How much change would she give you? Or he give you? What? How much? How much in change? What's the difference between these two numbers? Max? 30 cents. Now, how much did you still have in your hand when you paid for that? The 50 cents plus 30 cents is 80 cents. Is that enough for another?
No.
No.
No. Yep, you could buy a bag of chips, right? Good. Yep. But if you were just getting gum, you would only be able to buy 2. Correct? You
Yeah.
agree with that? Yep. Ariana?
Yeah, when you guys do cookies, but there's like, you have like $4. Because it's $2.20 for the cookie. It's more than $2.50. That's to get each thing.
If we got 4 bags of chips, 55 times 4 is 220. 220 cents, which is $2.20. So that's where our total cost for the 4 bags of chips come from. Is that what you're asking? The total cost of 4 bags of chips. And Ethan broke this down into 55 cents being 50 plus 5 and multiplying each one by 4. So this is 20 cents. This is 200 cents. So that's $2.20. Okay? Daria. Okay. Let's do the next one. Number 2. Again, we have a table. We have to set up the table and organize it. Mr. Evans' math class earned the following scores on their weekly quiz. 98, 89, blah, 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 all those numbers. How many students scored in the 70s, 80s, and 90s? So we're just going to organize the numbers. We're going to organize the numbers. Now, does anyone know what we could do to organize these numbers? There's a certain type of number table that we could do, Cole.
We could put like,
Do you remember what that number table is? Jen? Stem and leaf graph. What is it called? Stem and leaf graph. Do you know what that looks like?
yeah,
All right. So the stem in a stem and leaf graph is the first numbers, and the leaves are the last numbers. Okay. And then we still need a title. What's a title? Jeremiah, what's a title we could use? Yep. What would be?
okay. Math class scores.
Okay, math class scores. Good. Or if you have more room, Mr. Evans' weekly math class scores. Now, how are the numbers organized? When you do a stem and leaf graph, what's the first column look like? The numbers are organized from, wait. How are the stems organized? How are the stems organized? Do you remember? Ariana? From what? 7 to 9, or from least to greatest. Least to greatest. Now the stem in a stem and leaf graph is the first number. Okay? So we have some scores in the 70s, 80s, and 90s, right? Now, what we can do to organize this is go in order and write down the leaves for each of the stems. So, cross them out as you go. Could someone read the numbers for me? Read the numbers. Zoe? The first number is, no, on of the list,
Oh.
98. Cross that one out. So it's 98, right? What's the next one? Keep going, Zoe. 89. Cross that one out. Next one. 79. 79. Cross that one out. Next. 92. Cross that one out. Now, do we write the 9 for 92 again? No, the 9 is the stem. That's the first number. So this 9 and 2 refers to the number 92. We can look at the 2, and because its stem is 9, we know that the value is 92. Okay? Next. 93. Cross that one out. 87. Cross that out. 86. 95. 93? Did you say 93? 93. 75. 77. 76. 78. 79. 80. 92. 93. Oh, we're going off the chart. 97. 94. Is that all of them? Good. Now, the great thing about these is it works kind of like a tally chart. Okay? It's kind of like a tally chart, except that we can get more information from this. Okay? Which one had more scores? 90s. There were more scores in the 90s than any other one. Now we can look at that at a tally chart as well. But in the 90s, we could also look and see what was the highest score? 99. You couldn't do that if you just made tally marks. Okay? That's okay. Tally marks is okay, but what I'm trying to show you is that a stem and leaf graph can give you more information. You could answer more questions by looking at the stem and leaf graph. Okay? For example, you could quickly figure out which score occurred the most often. There's two 79s, right? Are there any 80s that are repeated? No. Are there any 90s that are repeated? Which ones? Twos and how many threes are there? That one occurred the most often, didn't it? Yep. So that one's called the mode when it occurs the most often. That's why this is useful. okay? The other reason that it's useful is that it kind of acts like a bar graph. Just by looking at the numbers, you can clearly see which one is the most. So it acts like a bar graph that way. Okay? So that's another thing that's useful about a stem and leaf graph. Now, I'm gonna help you set up one more table, and then I want you to finish the rest on your own. Number 3. Let's set up number 3. It says Victor earns $6.95 per hour. What does per mean? What does that mean? Per hour? Bryce?
That means like you get this much per hour, like you get like 2 cents per hour.
Yeah, and so then per, that word per means for every
It's for every hour.
for every 1 hour. He gets $6.95, right? He works between 1 and 5 hours each day. Make a table that shows how much he earns in 1, 2, 3, 4, and 5 hours. How much does he earn when he works for 3 hours? So we have a table. What is the title?
Oh. Victor's working hours.
Okay. Victor's
Working hours.
hourly, or Victor's wages maybe? What's wages mean?
Money.
Money? Yep. So Victor's wages. And then there's 2 columns. In yours, one thing different about yours this time is that it is set up not to be across this way, but one way that computers use more often to set things up is this way. So you could set up a column going this way, where the subjects are here. One of the subjects is the number of hours, right? And what are we trying to find? The total money, it's called total pay. The pay is the amount that he earned. Or you could write total earned. So, when you set it up this way, the subject goes that way. 1, 2, 3, 4, 5, and so on. And then they line up like this. So 1 hour is worth how much?
$6.95.
Right. $6.95. Then you have to figure out for 2, 3, 4, and 5 for your homework. Okay? And then answer the questions at the bottom.